4-5, simplifying algebraic fractions. 2 lessons ago, you worked on finding factor trees and finding the prime factorization of numbers. Last lesson, you found the greatest common factor for pairs of numbers or pairs of monomials. Today, we're actually going to use that information and use those skills to simplify an algebraic fraction. We're going to reduce it to lowest terms. Factor trees, still not changing. 25 is 5 times 5. 60 is 2 times 30. Remember, lowest prime numbers always on the left. 30 can be 2 times 15. 15 is not even, not divisible by 2. This time we move up to 3. It's 3 times 5. So, for 25, the prime factorization is 5 times 5. For 60, the prime factorization is 2 times 2 times 3 times 5. Now, at this point, traditionally, what we would do is we would find the greatest common factor is going to actually be 5, because that's all they have in common. Go ahead and circle it. And then we would do 25 and 60, divide them both by 5. And when we divide them both by 5, 25 divided by 5 is 5, and 60 divided by 5 is 12. And there we go, simple, the answer is done. That works great when we have simple numbers like this. But I'm going to show you something that's going to be a trick. It's going to make things a little bit easier for you. So I'm actually going to back up, and I'm going to erase all this little bit of work right here for you, finding the GCF, get that out of the way. And then I'm going to go up here to where we have 25 and 60 written in prime factorization. I'm going to draw a line like that. What I'm really doing is we have 25 over 60, the fraction. 25 over 60, 25 can be rewritten as 5 times 5. And 60 can be 2 times 2 times 3 times 5. So instead of having 25 over 60 as a fraction, we have 5 times 5 over 2 times 2 times 3 times 5. We write the prime factorizations as a fraction. Now, above, we circled the 5s that they had in common. I'm going to ask you a question that should key you into something we did earlier this year. Because you're such advanced math students, what happens to a 5 on the top and a 5 on the bottom? In other words, the ones that we circled for the greatest common factor, those actually cancel each other out in this prime factorization fraction that we've created. Make some room. And we can simplify this by saying that on the top is just the 5, it stays there, and then on the bottom we multiply the numbers together. 2 times 2 is 4, 4 times 3 is 12. So we can write the prime factorization in terms of a fraction, one prime factorization in the numerator, one prime factorization in the denominator, and then cancel out pairs of things that they have in common, and that leaves us with a fraction in simplest terms. Now, may not be the easiest thing to do or the most economical as far as saving your time with just numbers. But then again, we're in pre-algebra, and everything is not just numbers. We now have variables. So we are going to find the prime factorization for 16n and 18n squared p. 16 becomes 2 times 8. 2 is prime, 8 is composite. 8 becomes 2 times 4. 2 is prime, 4 is composite. And 4 becomes 2 times 2. The prime factorization for 18 is 2 times 9, the factor tree. 9 breaks down into 3 times 3. So we now have the factor trees for 16 and 18. Let's go ahead and rewrite 16n equals, let's go ahead and look back at the original problem, 16n over 18n squared p. We're going to rewrite that, the 16n, as the product of its primes. And you'll see from its factor trees that there are 4 2's, 2 times 2 times 2 times 2 times the variable n, which we now stick back on the end. 18 is 2 times 3 times 3, 2 times 3 times 3, and then n squared is actually going to be rewritten as n times the variable p. So we want everything in expanded form because really, what are we going to do now? We're going to cancel out the things that we would have circled that they have in common. They have a pair of 2's in common. They get canceled out. What else do they have in common? They have a pair of n's in common. We will cancel out a pair of n's. It is okay to cancel out several sets of things. You'll remember yesterday we had the a and the a and the a for one of the things we had to find the prime factorization for, and the other monomial we had to find a times a. We could cancel out a pair of two pairs of a's in that problem. At this point, we're going to simplify this algebraic expression, rewriting it as a fraction. On the top, we have 2 times 2 times 2, which is 8. 2 times 2 is 4, times 2 is 8. And on the bottom, we have 3 times 3 times n times p. 3 times 3 is 9. N and p don't do us any good, so we'll just have them there. So we've just simplified 16n over 8n squared p into its simplest form, 8 over 9np. This is the most economical way of doing this process. Your homework is book page 172, problems 14 through 44, the evens.